What's that almost invisible workhorse humming away inside your car? The one that actually has a huge impact on how it performs.
Ah, you must be talking about the mass airflow sensor.
Exactly. We're doing a deep dive into the MAF sensor today. It's this component you probably don't think about much, but wow, is it critical for your engine's performance and its fuel efficiency too?
It really is. The MAF sensor, fundamentally, its job is to measure the amount of air going into the engine. And not just the volume. Importantly, it measures the weight, the mass of the air.
By weight. Okay.
Yeah. And then it converts that measurement into like a voltage signal that changes, and it sends that straight to the car's main computer instantly.
Okay, let's unpack that a bit.
Yeah.
So the computer gets this really precise info about the air coming in. What does it actually do with it?
Well, think of the engine's computer like it's trying to manage this super precise chemical reaction, right?
Yeah.
Combustion. The MAF sensor gives it one of the absolute key ingredients, exactly how much air is coming in. And the computer takes that data, adds in info from other sensors like temperature, throttle position,
Right.
and uses all that to calculate the perfect amount of fuel to inject. It's aiming for that optimal burn.
Ah,
Uh,
okay. So it's that incredibly fine-tuned balance that lets modern engines, meet emission rules, but still give you decent power and economy.
That's the core of it, yeah. Getting that air-fuel ratio just right, like spot on.
Fascinating. So we're not just looking at why they're important, but also, and this seems crucial,
Yeah.
why just yanking one out and putting in a new one without really diagnosing the problem first,
Yeah,
well, that can cause more headaches.
absolutely. That's a huge part of this.
And we'll also touch on Walker Products, right?
Yeah.
And their focus on quality MAF sensors made right here in the U.S.
Yes, definitely. So modern engines, they rely heavily on getting accurate data from that MAF sensor. It's essential for, well, first, optimizing that air-fuel ratio we just talked about.
Right, the foundation.
Exactly. That balance is absolutely key for how your engine performs, delivering power smoothly and efficiently.
Makes perfect sense. If that mixes off, nothing else works right.
Right.
What else is the MAF sensor involved in?
Well, it's also a really big player in fuel efficiency.
Okay.
By making sure the engine isn't getting too much fuel or too little compared to the air. The MAF sensor helps your car sip fuel as economically as possible.
Good for the wallet.
Definitely. And then there's emissions control. A MAF sensor that's working correctly helps the engine burn fuel much more cleanly.
Which means fewer nasty pollutants coming out the tailpipe.
Precisely. So it's performance, economy, and cleaner air. Kind of a triple win.
It really is. Now, modern cars are just packed with sensors everywhere. How does the MAF fit into that whole network?
Yeah, it doesn't work alone. The MAF sensor works, hand in hand with other sensors. Think like the inlet air temperature sensor, the throttle position sensor.
Okay.
All this data gets fed into the onboard diagnostic system, the OBD-II system. That's basically your car's self-check system.
Got it.
And something interesting in turbocharged engines, because you're forcing air in, it gets more complex.
Right. Forced induction.
Exactly. So you'll often find MAF sensors working together with MAP sensors, manifold absolute pressure sensors. That gives even finer control over that air-fuel mix because of the added complexity.
It's amazing how these things all talk to each other.
Yeah.
But, what happens when this crucial MAF sensor starts acting up? What might you, the driver, actually notice?
Well, if an MAF sensor isn't reading right, you can run into a whole bunch of noticeable issues. Your car might suddenly be hard to start.
Or just won't start at all?
Or won't start at all, yeah. You could feel the engine kind of surging erratically while you're driving. Or it might just stall out on you.
Oh, wow.
And of course, the big one. The check engine light pops on your dashboard. That's a very common sign.
The dreaded light.
Yep. You'll probably also see your fuel economy take a nosedive. The engine might idle really rough, like it's shaking. And sometimes you might even notice more smoke or smell from the exhaust, indicating higher emissions.
Okay, that's quite a list of potential headaches. And yeah, when that check engine light comes on, it's so tempting to just assume, it's the MAF sensor, especially if you've heard of it.
That is a very common jump, and honestly, it's often wrong. See, when a sensor like the MAF acts up or gives a weird reading, the car's computer logs a specific code, a diagnostic trouble code, or DTC.
Right.
And an MAF issue will trigger certain codes. You might see things like P01011. That often means there's a problem with the MAF circuit's range or how it's performing.
Okay.
Then there's P01002, usually means the signal's too low. P01003, signal's too high. P0104 suggests it's like an intermittent problem, cutting in and out.
Okay, different flavors of failure.
Exactly. And there are others too. You might see P1100 or a whole range like P006A, P000B8, various codes from P000BC up to BF. Yeah, all related to airflow correlation or circuit issues. Plus, P0100, P010A through P010F, P061D, P2003, P200744. It's a whole family of potential codes.
So definitely not just one code tells the whole story. That really hammers home the point. What are some of the typical reasons an MAF sensor might actually fail? Is it usually the sensor itself just dying?
Sometimes, but often it's something else causing it to read incorrectly. A really common one is contamination.
Like dirt.
Yeah, dirt, oil mist from maybe a crankcase ventilation issue, stuff that gets onto the sensor element itself and messes up its readings.
Okay.
Another big one is the air filter. If your air filter is super dirty, clogged up, or maybe wasn't installed right and isn't sealing properly.
It lets junk through.
Exactly. It
Yeah.
lets contaminants get past and onto that sensitive MAF element. Then you have vacuum leaks.
Ah, unmetered air.
Precisely. Air sneaking into the intake after the MAF sensor throws off the computer's calculations because it doesn't know about that extra air.
Makes sense.
You could also have wiring problems, bad connections, corroded pins, frayed wires, or the intake boot, the rubber tube connecting things, might be cracked or loose.
Okay.
Even something further down the line, like a clogged catalytic converter or restricted exhaust, can mess with airflow dynamics and indirectly cause MAF codes.
Wow.
And just, road debris, little bits of stuff that somehow get past the filter and physically collect on the sensing wires or film inside the sensor, that happens too.
Man, it sounds like a lot of those potential causes aren't actually the MAF sensor failing, but more like problems around it making it read wrong.
That's it, exactly.
Which really brings us back to why just swapping the sensor without a proper diagnosis, probably not the best idea.
Definitely not. Seeing the check engine light and pulling a MAF-related code, it absolutely positively does not automatically mean you need a new MAF sensor.
Right.
Replacing it without digging deeper often just wastes your money, wastes your time, and crucially, might not even fix the original problem your car has.
Okay, so let's say my check engine light is on. I hook up my scanner, and bam, there's a MAF code, maybe P0101. What should I really do? Walk us through how a pro would tackle this.
Okay, first things first, like we mentioned. Use that OBD-II scanner, but check for all the trouble codes stored, not just the MAF one.
Look for buddies.
Yeah, exactly. Look for any additional codes that can give you really important clues. Maybe you have that P0101, but also a CRIN for an O2 sensor or an EVFP system leak that points you in a different direction.
Yeah, it makes total sense. The MAF isn't an island. Okay, after checking all the codes.
Step 2. Get your eyes on it. Do a careful visual inspection of the MAF sensor itself and the wiring harness going to it.
What are we looking for?
Obvious stuff first. Any cracks in the housing? Are the electrical pins corroded or bent? Are the wires frayed, melted, or maybe chewed by a critter?
Critters, yeah, that happens.
It does. And then look inside the sensor bore if you can. Can you see any obvious dirt, oily film, leaves, bug wings, anything on that little sensing element?
Okay, so a good visual check for anything out of place. What's step 3?
Step 3 is check the air filter and the whole intake path before the MAF sensor. Pull the air filter out. Is it filthy, clogged solid?
Could be restricting airflow.
Absolutely. That alone can cause incorrect MAF readings. Make sure it's the right filter for the car too, and that it's seated properly in the airbox, making a good seal. Also check the intake tube for blockages or debris.
Simple stuff, but easy to overlook, I bet. And that could definitely lead you down the wrong path. What's the next level of digging?
Okay, step 4 gets a bit more technical. You'll want to use a multimeter to actually test the MAF sensor's electrical output.
Measuring its signal.
Right. You check the voltage or maybe the frequency it's sending back to the computer. You need to do this with the engine idling and then again as you raise the RPMs.
And compare it to what?
Compare those readings to the specs from the vehicle manufacturer. They'll tell you what the signal should be at idle and under load. Generally you might see voltage from, say, 0.5 volts at idle, up to maybe 4.5 or 5 volts at higher RPMs. And critically, check the ground wire. It should have basically 0 volts.
Okay, so seeing if the sensor's actually putting out a signal and if it's in the ballpark. What's step 5?
Step 5 involves using a more advanced scan tool, one that can show you live data.
Real-time info.
Exactly. You watch the MAF sensor reading, usually in grams per second, jaggies while the engine's running. At idle, a typical reading might be, 2 to 7 grams for most cars.
Okay.
Then, as you smoothly increase the engine speed, you should see that Jaeger's reading increase smoothly and proportionally. You're looking for smooth changes, not sudden jumps, dropouts, or readings that seem totally stuck or erratic.
Watching it live like that must give a much better feel for how it's actually behaving. What comes after the live data scan?
Step 6 is some homework. Check for any technical service bulletins, TSBs.
From the car maker.
Yeah, issued by the vehicle manufacturer specifically about the MAF sensor on your year, make, and model. Sometimes they identify common problems, maybe have an updated diagnostic procedure, or even a redesigned part. It can save you a ton of diagnostic time.
That's a smart move. Always check if the manufacturer knows something you don't. What's step 7?
Step 7 is hunting for vacuum leaks again, but really thoroughly this time. We talked about unmetered air.
Right, air getting in after the sensor.
Exactly. So you need to meticulously inspect the intake manifold, the throttle body area, all the little vacuum hoses connected everywhere, cracks, loose fittings, anything.
How do you find tiny leaks?
Well, professionals often use a smoke machine. It fills the intake system with visible smoke under slight pressure.
And the smoke comes out where the leak is.
Precisely. It makes finding those sneaky, hard-to-spot leaks much, much easier.
Okay, smoke machine, that's cool. Step 8.
Step 8. Don't ignore the other end of the engine, the exhaust system.
How does that affect the MAF?
Well, think about it. If you have a restriction, like a partially plugged catalytic converter, it creates back pressure.
Ah, makes it harder for the engine to breathe out.
Right. And that can affect how air is drawn in, which can sometimes confuse the system and trigger MAF codes, even if the MAF sensor itself is okay. So checking for exhaust restrictions or even malfunctioning O2 sensors is part of a thorough diagnosis.
Wow, it really is all connected. Okay, almost there. Step 9.
Step 9 is to check the fuel system itself.
Why the fuel system for an airflow code?
Because sometimes problems like low fuel pressure or maybe fuel injectors that aren't spraying correctly can cause symptoms: rough running, poor performance that might look like a MAF sensor problem.
Ah, mimicking the symptoms.
Exactly. So doing a fuel pressure test and maybe checking injector balance rates helps rule out the fuel side as the root cause before you condemn the MAF.
Okay, really covered all the bases now. What's the very last thing? Step 10.
Step 10, and this is really a last resort after you've checked everything else, is to consider the engine control module, the ECM itself.
The main computer.
Yeah, it's rare, but sometimes a software glitch or even an internal failure in the ECM can cause it to misinterpret the signal coming from a perfectly good MAF sensor.
So the computer itself is the problem.
It can be. Sometimes a software reflash from the dealer can fix it. In very rare cases, the ECM might need replacement. But again, you only go there after exhausting all the other, much more likely possibilities.
Makes sense. And, okay, let's say we go through all that, and we actually do determine, yep, the MAF sensor is bad, we get a new one. Is there anything special we need to do after putting the new one in?
Yes, absolutely. Step 11, and don't skip this. Follow the vehicle manufacturer's specific relearn or adaptation procedure after installing that new MAF sensor.
Relearn, what does that mean?
Basically, you're telling the ECM, hey, you've got a new sensor here, learn its specific characteristics. Every sensor, even identical part numbers, can have tiny variations. This procedure lets the ECM calibrate itself to the exact flow readings of the new sensor.
And if you skip it?
If you skip it, the car might not run quite right, you might not get the best performance or fuel economy, and sometimes the check engine light can even come back on because the computer's expected values don't match the new sensor's actual readings perfectly. So yeah, the relearn is important.
Wow, that is a really thorough step-by-step process. Now, you mentioned contamination earlier. What about trying to clean a MAF sensor? People sell sprays for that.
Right, this comes up a lot, and it's important. Walker Products, based on all their testing and expertise, strongly advises against trying to clean MAF sensors with aerosol sprays or any other method.
Really? Why not?
Because the actual sensing element inside, whether it's a hot wire or a hot film, is incredibly delicate. Those sprays, even ones marketed for MAF sensors, can sometimes damage that element or leave residues that actually make the readings worse or cause it to fail completely later on.
So you could end up making things worse.
You absolutely could. If you suspect contamination is the issue, the safest, most reliable approach is generally to replace the sensor with a new quality unit. Trying to clean it is often just too risky for damaging that sensitive part.
Okay, that is really good advice. Avoid the spray cans. It just reinforces how taking the time to do that proper, thorough diagnosis we just walked through can save you a lot of grief time, money, and just frustration.
Couldn't agree more. Accurate diagnosis gets you to the real problem faster. It stops you from just throwing parts at the car hoping something sticks, and it gets your vehicle back on the road reliably with minimum downtime.
Definitely. Now let's shift gears slightly and talk about getting that replacement part. You mentioned Walker Products earlier. Tell us a bit more about them and their MAF sensors.
Sure, Walker Products has actually been around for a long time, since 1946. So they have a deep history in the automotive aftermarket. They've built a strong reputation as a premier supplier for all sorts of engine management components, and MAF sensors are definitely a big focus for them.
And their approach is focused on quality.
Very much so. They have a really strong commitment to meeting and often exceeding the original equipment, the OE specifications. And they put a lot of emphasis on rigorous quality standards throughout their manufacturing.
And one thing you mentioned, Walker emphasizes their MAF sensors are always 100% new, never remanufactured. Why is that distinction important?
Yeah, that's a key point for them. Using only brand new components means you're getting a sensor built to the original engineering specs with no prior wear or potential hidden issues.
Unlike a remanufactured part.
Right. Remanufactured sensors, while they might seem cheaper initially, have obviously been used before. They've been cleaned, maybe had some parts replaced, but they still got history. A new sensor from Walker offers predictable, reliable performance and longevity right out of the box. It aligns with their whole focus on quality.
Walker also makes a point of saying their MAF sensors are made in the USA in facilities that are ISO and IATF certified. For listeners who aren't familiar, what do those certifications really mean for the product?
Those certifications, ISO 9001 and especially IATF 16949, are basically the gold standard for quality management in the auto industry.
Okay.
Having them means Walker Products has proven they have robust, consistent processes for everything from design and development to production and testing of their MAF sensors. It signifies a serious commitment to quality control. They even use advanced stuff like robotic assembly for the printed circuit boards, PCBs, and robotic soldering to ensure that precision and consistency.
That definitely sounds like a high level of manufacturing control. I also read that Walker customizes the circuit boards inside their sensors. How does that work and why is it beneficial?
This is pretty interesting. They actually program the circuit boards to precisely mimic the exact signal curve that the original OE sensor for that specific car, truck, engine combination is supposed to produce.
So it's not just a generic sensor.
Not at all. They tune it for the specific application. This dedication to matching the OE signal ensures that when you install a Walker MAF, the engine's computer gets the data it expects, leading to accurate fuel calculations, smooth performance, and reliability that really meets or exceeds what the original part did. They also put effort into tuning the actual airflow characteristics of the sensor housing itself to match the original.
That level of application-specific tuning sounds really important for making sure it works correctly in your vehicle. Now, I understand Walker strategically focuses on making the top 50% of the MAF part numbers sold in the U.S. What's the idea behind that?
Yeah, by concentrating their U.S. manufacturing on the highest volume, most commonly replaced MAF sensors, they ensure they have excellent availability of high-quality new sensors for the cars and trucks most people are driving.
Makes sense. Focus where the demand is.
Right. It benefits repair shops and DIRs alike. If you need an MAF for a popular vehicle, chances are Walker Products has a top-notch, readily available option manufactured to those high standards.
I also noticed they offer choices. You can get just the sensor only, or a complete sensor and housing assembly. What's the difference, and when would you choose one over the other?
Good question. The sensor-only option, where you just replace the electronic sensor part itself, usually held in by a couple of screws, can often be the more budget-friendly way to go.
Cheaper.
Generally, yes. However, replacing the complete assembly, which includes the sensor pre-installed in its plastic or metal housing or tube section, well, some manufacturers actually recommend doing that.
Why is that?
It guarantees the sensor goes into a perfectly clean environment, no chance of dirt from the old housing getting on the new sensor. It can also be a bit easier and safer, reducing the risk of damaging the delicate sensor element when trying to install just the probe into the old housing.
Okay, pros and cons.
Exactly. And Walker is thoughtful here. For their sensor-only MFs, they actually include the special security Torx bit you often need, plus new screws. That's a nice touch.
Yeah, saves a trip to the tool store.
Definitely. They also offer what they call full service kits, or FSKs, for some applications. These include the sensor and a new wiring pigtail connector for the vehicle side. That's really handy if the original connector on the car's harness is damaged, corroded, or brittle.
It sounds like they've really thought through the practicalities of replacing these things. And their overall coverage looks pretty wide-ranging, too.
It really really is. They cover a huge variety of vehicles: cars, light trucks, domestic, import, running on gas, diesel, flex fuel, even LPG and CNG. And their coverage goes way back, from model years around 1982 right up to current vehicles. Plus, reinforcing that quality commitment, they do 100% production testing and on-vehicle testing to make sure their sensors perform correctly and help maintain the proper long-term fuel trim percentages the OE intended.
Okay, so let's wrap this up. We've really dug into how vital that mass airflow sensor is for just about every aspect of modern engine operation. We've stressed multiple times how crucial proper diagnosis is before you even think about replacing one.
Absolutely critical. Don't just swap parts.
And we've learned about Walker Products' dedication to quality, making 100% new MAF sensors, tuned for specific vehicles, with a big focus on those high-demand part numbers manufactured right here in their certified U.S. facilities.
That sums it up well. The MAF sensor, yeah, it's small, but its impact is massive. Understanding how it works and knowing how to properly diagnose issues can save you real headaches. And it's good to know there are companies like Walker Products focused on providing reliable, high-quality new replacements when you genuinely need one.
So here's a final thought to leave you with. We've seen how critical precise airflow measurement is. It makes you wonder, what other seemingly small, maybe overlooked components in your vehicle might be having a similarly huge impact on its performance or efficiency without you even realizing it? Something to think about.
Good question. Always more to learn about these complex machines.
For sure. And if you want more detailed info on mass airflow sensors or want to check out Walker Products' full lineup of engine management solutions, head over to walkerproducts.com.